Everyone, good morning, good afternoon, depending on the time you are following. So in our today lesson, we will be looking at how we can determine the depreciation of an asset using the reducing balance method. So unlike the constant method, what differentiates it from the reducing balance method is that with the reducing balance, you are going to be dealing with two rates. But with the constant method, you use only one rate, or the straight line method. So with this reducing balance method, we are going to be using two rates. So one of the rate is called a constant rate. We have the constant rate, and the other is the reducing or the decreasing rate. This constant rate is mostly abbreviated as RC, and the decreasing rate abbreviated as RD. So our constant rate is always gotten using the formula 100 except that the rate was given. If it is not given in the question, you are going to use 100 divided by n, which is the duration. And to get the reducing or the decreasing rate, you are going to use the formula 100 divided by n, which is the duration, times c. This c here is the coefficient, and these coefficients, they are often used with respect to the duration of the asset. Let's say an asset which is to be depreciated for a period of 2 years, its c is going to be different from an asset which is going to depreciate for a period of 4 years. Alright, so with respect to all this, we are going to dive into a question and solve it together. So right in front of us here, we are having a question which goes thus. They say a fixed asset with a lifespan of 5 years was acquired for 5 million francs on the 1st of January 2018. You are required to present a table of depreciation for the fixed asset using the reducing balance method. So, solution. So this is our depreciation table that we are going to use. So we are going to have two rates. We have the RC, which is the constant rate as they call, and the reducing rate as well. So this reducing rate is rather, or decreasing rate is rather constant throughout. Meanwhile, the other rate, the constant rate, is the one that is going to be alternating. So we are going to see more as we will be solving this exercise. Awesome. So in order to determine from the question, our n has been given to be 5 years. So n is 5 years. So our normal rate RC, our constant rate RC, will be equal to RC will be equal to 100 divided by 5, which is the duration. When you divide 100 by 5, you are going to have 20, right? We are going to have 20. And then our reducing rate. So concerning our constant C, this is the ceiling that we'll be using. So with the lifespan, when the lifespan of an asset is from 2 to 4 years, our coefficient will multiply by 1.5. From 5 years to 6 years, we use 2.0, and above 6 years, we multiply by 2.5. So with respect to this exercise, I hope it is visible. So this is that. So our reducing or decreasing rate will be equal to 100 divided by 5 you take 100 divided by 5 equal to times. So since it is 5 years, they say from 5 to 6 years is 2.0. So times 2. 2.0 is the same as 2, right? Which we are going to have which will be 40%. Awesome. Sorry, so this is our radar we are going to be using in our question. We have 20% and 40%, right? So that is that. I'll minimize this. Awesome. This is that. All right. So in our durations here, we are going to number, since this is from 2018, we have 2018. We just put 1 year to 2018, 2019, 2020, 2021, 2022. Awesome. 1, 2, 3, 4, 5. So this is the duration, the entire life cycle of the fixed asset. And our depreciation base now is the original amount, or we say the OV, which is 5 million. Which is 5 million. Then our reducing rate in this case, we have from our calculation we have about 20%. So 20%. And then our reducing rate is 40%. So this reducing rate rather, or the decreasing rate, is going to be constant or true. This is the one that will be alternating. And the rate that we are going to use to calculate, the rate that we are going to use to calculate our annuity here will depend on, in fact, we are going to compare the two and take the one that is the highest. We are going to be using only the highest rates altogether, only the highest rate. Awesome. So let's continue. So the annuity here, we are going to use the formula equal to our base times, please take note, times our rate, which is the highest. 5 million times 40%. So we have 200,000. So what will be our accumulated depreciation in this case? Our accumulated depreciation in this case is T equal to 2 million, right? Sorry, it's 2 million, not 200K. It's T equal to 2 million. Since there is nothing in year 0. And then our net accounting value here will be what? Will be the accumulated, will be the total amount, or the original value, minus the depreciation amount, or minus the annuity. Since the annuity and the accumulated depreciation here, they are the same, so we say minus any amount, we have the same figure. So which is equal to our depreciation base, or the original value, minus the accumulated depreciation. We are going to have 3 million. So this accumulated depreciation is the amount that we are going to use now in year 2. Please take note, this is the reducing balance method. So this is the amount that we are going to use in year 2. So to know the rate we are going to use here, right, we are going to take that, this is already year 2. Since the duration here, to know this rate is 20%, we took this, we took 100 divided by 5, right, for the entire 5 years. Since now is the second year, we are going to divide it by 4. Meaning as you are going down, please, that's how the rates are alternating. That's how this rate is changing. Take note, and take note very well. So the first year you divide by 5, which is the entire life cycle, right, of the assets. Second year now, the rate will also reduce by 1. Sorry, the duration here will also reduce by 1. So to know the rate here, we are going to use the second rate. We are going to use 100 divided by 100 divided by 4, right? 100 divided by 4. So we see that what? We are going to have 25%. This is 25%. So between 25 and 40%, which one is higher? It's still 40% that is higher. So our annuity is going to be calculated on 40% as well. So which is equal to this 3 million times 40%. We are going to have 1,200,000. So in this case, what will be our accumulated depreciation? Will be equal to the depreciation in year 1 plus the annuity of the year of the following year. So the total will be 3,200,000. Take note, please. We took this plus this in order to have this. So now the net accounting value at the end now will be equal to the depreciation base. Sorry. Is equal to rather the OV, which is the original value, minus the accumulated depreciation. So which will have what? 1,800,000. Our NAV, net accounting value here that we are using. This amount is calculated entirely on the original value of the asset, which is what? 5 million. But the rates, they are calculated based on the amount that we have with respect to the various years. But the NAV is calculated with respect to the original value altogether. So the amount that we have here will still equal to the amount at the end of the year for your 2019. Awesome. All right. So to know the rate here now, we say what? Equal to, so since here was divided by 5, here divided by 4, so here will be divided by 3. 100 divided by 3. Awesome. So I have 33.33%. All this amount they are in percentage. 33.33%, because they are all in percentage because we are using by 100. 33.33%. So between 33.33% and 40%, 40% is still higher. So our annuity in this case is going to be calculated using 40%. So equal to this times this. So we are going to have 720,000. Our accumulated depreciation in this case will be what? Equal to this as well plus this. Well, 3,920,000. 3,920,000. So our net accounting value here will be equal to our OV minus this 3.92 M, which will have what? 1,080,000. 1,080,000. The 1,080,000 will also be transferred to here. 1,080,000. All right. So the rate here as well, we have 100 divided by this already the second year, the fourth year, sorry, divided by 2. Take note, please. Here was divided by 5, divided by 4, divided by 3, and here is already divided by 2, or what? 50%. So between 50 and 40%, which one is higher? 50%, right? So in this case, we are going to use by 50%. So I have equal to this times 50%. We are going to have 540,000. So our accumulated depreciation will be this plus this of 4,460,000, and then our net accounting value will be equal to what? OV minus the accumulated depreciation, which will be what? 540,000. Awesome. So our amount here, the amount at the end of the period here, also be transferred to year for the fifth year, right? So the rate here will be what? 100 divided by 1. Sorry. 100 divided by 1, which will be what? 100. Saying here is divided by 5, divided by 4, divided by 3, divided by 2, divided by 1. Awesome. So between 100% and 40%, which one is higher? 100%, right? So I've equal to this times this 100%. I'm typing manually because this thing is not having percentage linked to it. Times 100%. So what? 540,000, right? So the accumulated depreciation now will be equal to this plus this. Awesome. Our 5 million. So our NAV here will be equal to this minus this. Awesome. See that finally the asset has completely depreciated, right? The asset has completely depreciated completely. So thank you very much for following. We are looking forward to see you in our next class. So keep learning, keep saving, and keep changing your world. Cheers.